Good morning, students. Today I'd like to deliver a lecture on structural equations model. First of all, I need to talk about observed variables. Basically, AMOS is a program designed for estimating structural equations models. There are two ways to set up AMOS models, but this handout is only about the graphing method. There are few conventions in these methods that apply to AMOS. They include exogenous observed variables are represented inside two rectangles, and there are variables that are named in your data set. Secondly, endogenous variables that are observed are represented inside the rectangles. These are variables that are named in your data set, and there is an associated error term linked to them. So in summary, exogenous observed variables are going to be the variables measured by the questionnaires, of course, and recorded in the data set, and that exogenous observed variables would be represented inside the rectangles. Also, endogenous variables, that would be the dependent variable, which is also observed, are represented inside the rectangles as well. So both observed variables conventionally are going to be represented inside the rectangles. Unobserved variables, all unobserved variables, sometimes called latent exogenous variables, latent endogenous variables, the specified error terms associated with endogenous variables and the error terms that capture measurement error for indicators of latent variables are represented in ovals as opposed to rectangles. So unobserved latent variables are conventionally represented in ovals. The names given to these variables are not variables that are in your data set. Of course, in your data set you have observed variables, indicator variables. The variable names already designated in the data set. However, we are now going to extract unobserved variables or factors out of a multiple number of observed variables, and then the researcher will name the unobserved variables. So the naming of unobserved variables is supposed to be done by each researcher. The models are estimated of variance covariance matrices. Thus no intercepts are estimated, just variables are going to be estimated. These can be computed, however, by asking AMOS to do so. So I'm now talking about the type of data set. The data set used in the structural equations model will be composed of variance covariance matrices. So when you open AMOS, you see two windows. One is a blank screen that will be where you draw the model, and the other one is a set of buttons that are tools that help you develop your models. Okay, we need to understand the purpose of structural equations modeling. Number one, the SEM is to estimate causal relationships simultaneously among multiple latent variables. Latent variables is sometimes interchangeably called unobserved variables. So the number one purpose of structural equations model is to estimate pathway coefficients. Second, SEM is to measure latent variables by employing multiple indicators. So we are now employing multiple indicator strategy to draw unobserved components out of multiple number of observed variables represented inside rectangles. Third, therefore, we can minimize unspecified random measurement errors in the process of measuring latent variables. So, by employing the structural equations model, we can very successfully control the measurement errors or minimize the measurement errors unwanted in the estimation project. So the latent variables will be drawn by eliminating or minimizing the measurement errors as much as we can. That's great, the merit of the structural equations model. So in the framework of structural equations model, we are supposed to estimate total effects, which is defined as the summation of direct and indirect effects. So if we decompose the total effect in the third line, we can think of direct effect plus indirect effect. So in other words, total effects will be decomposed into direct effect and indirect effect. Okay, so the indirect effect will be estimated by multiplying the estimate of in coefficient and the estimate of output coefficient. Statistical significance will be evaluated by taking a look at the size of p-values. Of course, the p-value should be lower than 0.05 for recognizing the coefficient as statistically significant for 5% level of significance. For the significance test of indirect effect, we normally employ the bootstrapping methods. So bootstrapping methods will enable us to evaluate the statistical significance of indirect effect. So let me summarize. Statistical significance of indirect effect coefficient will be evaluated by bootstrapping p-value that should be less than 0.05 for 5% level of significance. Okay, all latent variables are gonna be represented inside ovals. So if we take a look at the picture now, we are now think of 4 unobserved variables, latent variables. They are family environment, academic capability in the exogenous part, and academic aspiration and academic achievement in the endogenous part. So I'm gonna investigate the statistical association running from the exogenous parts of family environment and academic capability up to the destination of academic aspiration and academic achievement. So once again, I would like to stress that those 4 variables are latent variables and unobserved variables. Very abstract type of variables that cannot easily be specified or that cannot be easily measured in a normal questionnaire setup. So those 4 kinds of latent variables are gonna be drawn by multiple observation of the observed indicators. That's the strategy of the confirmatory factor analysis of structural equations model. Excellent. So now I'm investigating the effect of students' family environment on academic achievement, running from family environment up to academic achievement. As you can easily see, the family environment will be drawn out of multiple number of observed indicators such as family income, father's education years, mother's education years in the exogenous part. Exogenous means coming from outside. So the effect is now coming from outside. So that's the starting point of the arrow sign running from family environment to academic achievement. Let's take a look at the endogenous part. There we have academic achievement. So it is composed of two the indicators. First, language test score, and second, math test score. So in summary, the academic achievement is going to be drawn out of two observed indicators of language test score and math test score. So as an investor, I'm now interested in the causal relationship running from the cause of family environment to the result of academic achievement. Excellent. So this is the full model we are interested in investigating the association. So this is the title of Research on Determinants of Academic Performance. As you can see, how many exogenous latent variables? Basically two exogenous latent variables of family environment and academic capabilities will begin the causal relationship as the causal part. Secondly, how many endogenous variables? Two. Basically, academic aspiration and academic achievement are going to be the endogenous latent variables. Very excellent. So we are now dealing with four latent variables. All relationships are related with each other. The indirect effect is denoted in orange color, inbound effect and outbound effect. So if you multiply the inbound and outbound effect, then you can calculate the indirect effect of coefficient estimate. Okay, how about the pink arrows? They are direct effect. How many direct effects now? Three direct effects running from academic capability to academic aspiration, and family environment to academic achievement, and academic capability to academic achievement. Very excellent. Three direct effect and one indirect effect. Very excellent. And also another indirect effect will start from academic capability through the mediator of aspiration, academic aspiration up to the academic achievement. Very excellent. How many observed variables in this project? Basically 9. 5 exogenous observed variables and 4 endogenous observed variables. 3 exogenous observed variables will produce 1 latent variable exogenous of family environment. 2 observed exogenous variables will produce 1 latent variable of exogenous part, academic capabilities, and 2 endogenous observed variables will produce academic aspiration, and 2 endogenous variables will produce academic achievement. So there are 2 kinds of endogenous latent variable. First one is the mediator. Mediator is the variable located in the middle of the pathways of indirect effect running from exogenous to final endogenous part. So in this example, that mediator is academic aspiration. Okay, final endogenous variable is academic achievement. In this case, the academic achievement is the final destination and the end point of the causal relationships. Very excellent. Okay, this picture shows the structure of the data set we are going to use in structural equations model. Two things I need to mention. This table is variance and covariance matrices. So all diagonal element written in blue is variances. So how many variances are appearing in this table? 9, because we have 9 observed variables. Out of 9, 4 endogenous observed variables and 5 exogenous variables. So in total 9 variances does appear in the table, and the other off-diagonal terms written in black are called variances. That happen at the cross point of each related variables. For example, if you take y1 and y2, the variance is 0.792. How about this one? y1 and y3, the variance 1.027, something like that. So we have off-diagonal elements which is representing the variances of corresponding associated two variables. Very excellent. So that's the comment 1. Second comment is this. Basically, this variance covariance matrix will be computed automatically by the software of Amos. Very quickly, very nicely, very easily. So we don't have to worry about that for the calculation of this variance covariance matrices. So you can simply upload the SPSS format of data set, and automatically inside the algorithm or software, the computer will transform the SPSS type of data set into this variance covariance matrices. So let me check up the definition of variance and covariance in this slide. Variance of first of all, covariance is the difference between x variables and y variables, and actually the multiplication, inner product of the x difference and y difference, and then divide by the degree of freedom of n-1. So correlation will be calculated by dividing the covariance value in the by the denominator of standard deviation x times standard deviation y. So optimization principles. So inside the algorithm, the structure equations model is supposed to calculate the minimization of the distance between the sample covariance matrix, which is already given information from outside, and the fitted matrix, and then the algorithm of the software will minimize the difference between original matrix and fitted matrix to choose the best coefficients of the pathway estimates. Okay, that's the same principle of the regression. In the regression, as you recall, the principle of regression, least square method, actually, there we tried to minimize the original value of y and the fitted value of y. To minimize that, we want to we wanted to specify or recover the specific estimate of alpha and beta, alpha hat and beta hat. That's the y-intercept and coefficient and actual slope coefficient. That's the basic idea of least square method used or adopted in the regression analysis. Simply, we are now trying to minimize the summated square of residuals in the least square method of regression. So that's the basic idea that can be applied to the structure equations model and estimation of the pathway coefficient. Very wonderful. Thank you. This is another repetition of the principle of choosing the pathway coefficient in structure equations model. We are now trying to estimate structure equations model by minimizing the distance between original matrix and fit-in matrix and specify the estimate of pathway coefficient. In other words, the data should be decomposed of model, estimate, and residuals. So we want to minimize the residuals by selecting the right vector of coefficients. Thank you. So what is total effect in this picture running from IQ on GPA of students in the university? Basically, our exogenous part is IQ, the intelligence quotient, through aptitude mind, mindset. So this is the variable measuring the aptitude of mind. And then we can imagine the final destination of GPA score of college students. So there are two ways of the effects running from IQ to GPA. First one is direct effect, actually represented in the pink, and the indirect effect represented in orange. So we can have the indirect effect by multiplying in coefficient and out coefficient, and the direct effect, and then summate them all to produce the total effect. That's wonderful. Okay, so let me summarize what we have discussed so far. So we are now dealing with direct effect in pink and indirect effect in orange or yellow. So the finally total effect will be the summation of direct effect and indirect effect. The direct effect was 0.501. Indirect effect is 0.017. How would you get? By multiplying the in coefficient and out coefficient, and then total effect is 0.518. The significant test, standard error is in bracket, so t-value is for direct effect is 0.57. We can say that because it's lower than 1.96, so it is statistically insignificant at 5%. How about indirect effect? 0.18 t-score and 0.50 t-score, so it's insignificant again. So we can say total effect is insignificant. But actually in the real field, as a researcher, we can try to significant test of the estimate pathway coefficient through Amos estimation process. Basically at that time we have bootstrapping method to evaluate the statistical significance of in coefficient and out coefficient, and the multiplication of indirect effect of the multiplication of in coefficient and out coefficient will produce indirect effect, and that indirect effect is subject to the significant test performed by the bootstrapping method. So I will talk about that in the practical part later. So critical ratio, if you perform SEM using Amos, then you can easily find the critical ratios C dot R dot, which represents critical ratios. At that time, we should understand the level of status of level of significance. If you have a critical ratio is great, which is greater than 2.58, so we can say that is significant at 1%, two-tailed test. If the critical ratio is greater than 1.96, you can say that its statistical significant at 5% two-tails. If it's greater than 1.649, significant at 10% two-tails. P-value, if p-value is less than 0.01, at 1% significant. If it's lower than 5%, significant at 5%. If it is lower than 0.1, significant at 10%. So finally, I needed to mention about goodness of fit index and acceptance ranges. If you finish the estimation of Amos model, your graphic interface, in your graphic interface, then if you take a look at the textbook report, text report, summarizing the results of your estimation, then you have a couple of set of goodness of fit indices starting from chi-square and chi-square divided by degree of freedom, and AGFI, and AIC, BFI, CAIC, something like that. Aggregate goodness of fit index, archaic information criteria, Bayesian fit index, something like that. A number of goodness of fit indexes, and we have now acceptance range here. So you need to compare your obtained estimate of goodness of fit and the acceptance range. If your estimated goodness of fit index should include in the acceptance range, then you can say that is acceptable. Otherwise, it is not. Thank you. So some more goodness of fit index represented: archaic information criteria, consistent archaic information criteria, Bayesian information criteria, expected cross-validation index, something like that. Okay. Now I'm ready to exercise using real data and Amos. So Amos software is now provided through the iCampus. I have already uploaded iCampus software on the Amos software on the iCampus for the section 15. So you can download, and then you can unzip and you can install the Amos software in your personal computer, and then just follow me as indicated in the manual I have included in my lecture note here. Okay, let's start. If you open up Amos, then you have a beautiful picture of the starting screen. Two parts. First, the graphic part on the right hand side, there's a campus, and you can draw your model over the sheet. And second, the buttons, a group of buttons to control your analysis, to perform your analysis. Okay, number one, you need to go to view and then take interface properties. Then you have a dialog box like this, and we need to designate landscape A4. So portrait means the vertical rectangle, and landscape means the horizontal shape of rectangle over of the screen. So second, we needed to draw file and upload the data files. First go to file and data files, and then after checking your data appearing on the window, then you can click the OK. So file, data file, and file names, and then in the dialog box you are supposed to pick up the data you want to analyze, and then OK. So alright, this data has been uploaded on iCampus. You can download, and then you can also perform the data using your software as well. Second, file, and then data files and view files, view data. So it's a variance, covariance matrices. As I have already mentioned, it's data of variance, covariance information transformed automatically through the software we are now using of Amos. Off-diagonal terms represent the variances of each corresponding variable, both endogenous and exogenous. The second one is the covariance values occurring at the cross point of each two corresponding variables. Excellent. So I'm trying to draw the model. First, let me check the oval form, and then if you click here, left click, don't remove, just stay click on left hand side of the mouse, and just draw back. Then you will have a oval form over the white sheet, and you can draw the latent variables. Second thing is the crown. In this process, we can click the crown and locate cursor on circle and click 3 times. Then you will figure out the 3 branches newly appear linked over the oval, and then click right. You have a dialog box. In the middle you have the rotate section, and then rotate, click on rotate, and 3 times click left 3 times. Then the crown will move around clockwise. Then if you 3 times click 3 times, you have a picture like this, figure like this. Okay, let's think about oval. What does it represent? It represents the latent variables or unobserved variables. Let's take a look at the rectangles, 3 rectangles, which means 3 observed indicators will produce 1 unobserved latent variable in this example, and measurement errors. 3 measurement errors associated with each unobserved variables. So I will continue the same process 4 times to draw 4 latent variables extracted from multiple number of observed indicator variables. Alright, 4 latent variables now does appear over the spreadsheet, and we have a beautiful picture. And I'm now trying to link to draw the pathway coefficient. Okay, latent variables in the middle, mediator. So in coefficient and out coefficient, pathway, and direct effect, and direct effect. So 4 direct effects and 2 indirect effects. First one and second one. Very beautiful. Thank you. Okay, then I will click on the pawn of chess game, uh, and then move the cursor and locate it on the corresponding endogenous latent variable and click left. Okay, then the pawn, which is structural error. uh, so structural error newly does appear over the oval. I click left, and one more time the same job to do for producing the second structural error here. No problem, very beautiful, wonderful. Okay, let's go to view here, view and variables in dataset. So you are now supposed to choose the variables in dataset among the list of dialog box, and then click left. We have variables in dataset here appearing just in the middle of the canvas, and then we can move the variables and then link each variable to the corresponding observed variables. So click on the observed variables and drag and drop x1, x2, x3, something like that way, repetitiously. So I'm now linking all corresponding observed variables in the sign of rectangle, which is observed variables x1, x2, x3, x4, x5, and then y1, y2, y3, y4. So all four variables will be matched through drag and drop process from data variables in data dialog box. Okay, the next one is name. Name the errors and latent variables. First of all, errors. So you are gonna locate your cursor each corresponding errors, and then click on left click, locate it on target place, and click right. Actually, click right. Then object properties are gonna be chosen out of the list of dialog box, and you are supposed to plug in the relevant names of measurement errors E1, E2, E3, E4, something like that, in the box of variable names or variable names continuously. So put the name you want to designate in the middle window, not in the bottom window, just in the middle window. And then we are supposed to provide the relevant associated names of latent variables. So locate cursor on target place, click right, and object properties and academic achievement, the specific name for the specific location of latent variables in the box of variable name. To move the model, use icons of hand fingers. One finger, forefinger, and short fingers. One finger will designate just the line. Forefinger will designate all models. And short finger indicates the removal of the designation of the block. And then you can move the corresponding activated lines or the model. Use this fire engine icon, no problem. Okay, now we are ready to designate the options of analysis. First, go to view. Second, analysis properties, and then estimation, and then designate the type of analysis for maximum likelihood. Second, go to output, and please check three things: standard estimates, indirect, direct, and total effects, and critical ratios for differences. And then go to bootstrap here, bootstrap. Go to bootstrap here, and then check the three things: perform, bootstrap, bias corrected confidence intervals, and Monte Carlo. And go to analyze, and then click the calculate estimates in the list of dialog, and then check the standardized estimates. In this class, I strongly recommend to choose standard estimates as opposed to unstandardized estimates. Standard estimates is the unit fixed. So unit is the fixed coefficient estimate regardless of the units. So you can use standard estimates. That estimate should range from -1 to 1. So it's looking nice to check the strength of statistical association in comparison of many pathways. So the higher value of coefficients represents stronger statistical association in the corresponding pathway coefficient as opposed to other corresponding pathway coefficients. And then just click the upper small arrow. Then your coefficient estimates will appear on the pictures. So in order to do that, okay, just calculate estimates, then you can wait, then algorithm will go on. If they don't produce any error sign, then the software will ask you what kind of save file name for save the analysis. Then you can put in your saving name and then close. Right after you close up the dialog box asking for save name, the software will produce your estimates in the left hand side, and then just click the arrow button. Then you have a beautiful picture associated with estimate coefficients. Okay, let me check the text outputs. First, I need to go to view, and then in the final part or bottom part of the dialog list, you can choose the text outputs, and the text outputs ask you or provide you the information of number of distinct sample moments. That's the number of data. Second thing is the number of parameters, and the difference is degree of freedom. Okay, chi-square, degrees of freedom, probabilities. And then go to view text output, estimates. Go to estimates and scalars and check the regression rates. The p-values represent the statistical significance at 1%, 5%, and 10%. So 3 stars means p-value less than 0.001 is very significant. So this is 1% significant. This one is 10% significance. Okay. Please go to regression ways. Then scalars, estimate, scalars, regression ways. We have p-values. If you want to check up the standard regression estimates as opposed to unstandardized regression estimates as before, you can specifically check up the second button named as standardized regression ways. Then you can click on that. Then you have beautiful estimates ranging from -1 to 1, representing the strengths of statistical association regardless of the measurement units. That is standardized regression ways as opposed to unstandardized regression ways. Okay, if you want to check up the total effects, direct effects, and indirect effects, you can just click on matrices as opposed to estimates. So if you check up estimates and then matrix rather than scalars, then you have calculated total effect, indirect effect, and direct effects. Just to view text output, estimates, and matrices, and you have multiple association among the latent variables. Very beautiful, very beautiful. And then standardized total effect. In this picture, we have unstandardized total effects here, and standardized total effect, the second button, not in the first button, second button. Standardized total effects will produce you the standardized coefficient pathway estimates, which is standard total effect. Secondly, standardized direct effect, the fourth button in pink. Standardized indirect effect, the sixth button in green. Standardized indirect effect, running from academic capability, academic performance, something like that. Sorry for Korean. The basic idea is academic capability, family environment, academic aspiration, and academic achievement. Very nice. Standardized indirect effects. Okay. Finally, if you want to have the statistical significance about the standardized indirect effect, so two-tailed significant test, matrices, go to matrices, estimates, matrices, and standardized indirect effect, and then bias corrected percentile method, bootstrap confidence, and then bias corrected percentile method, and then finally two-tailed significance test. And then if you want to check up the text outputs and model fit, then we have a multiple model fit here. Absolute goodness of fit index, incremental goodness of fit index, parsimonious adjusted goodness of fit index. Actually, three categories of goodness of fit index are gonna be employed in SPSS and AMOS. First one is absolute goodness of fit index. Second, incremental goodness of fit index or baseline comparisons. Third one is parsimonious adjusted measures. So goodness of fit index, chi-square divided by degree of freedoms, and baseline goodness of this one is absolute goodness of fit index. The second thing is baseline goodness of fit index. Finally, parsimony adjusted goodness of fit index. Very nice. So you can check up the table I have suggested for acceptance range of the goodness of fit index in the previous slides. So you can check up the range, and if it does work, then you can say that, all right, this is very good goodness of fit index. Otherwise, it is not good enough for the goodness of fit or fitness. Excellent. So in order to exercise your internalized capability of analyzing structural equations model, I uploaded assignment 8 associated with the data set of assignment under bar 8. So why don't you download those two information. One is about question, the problems, homework questions and problems included in assignment 8. The second thing is the data set titled assignment under bar 8 for the homework. And then why don't you perform the structural equations model analysis using AMOS, and then complete the homework. Why don't you try the upload your completed data and then and completed homework or assignment. Thank you very much, students. I hope you enjoy all exercises, all lectures repeatedly. I hope you enjoy the program. I hope to see you in Korea. God bless you, and please take peace in mind, even among the COVID-19 environment. All right, thank you very much. Hope to see you. Bye bye.